In this lesson, we're going to explore some of the balance you might want to take between fluency and strategy, because initially developing strategies does take some time, and yet with fluency we need to get a little faster. In addition to that, we'll be suggesting a possible sequence for your strategy work with children, and especially our focus will be on helping children develop the big ideas of math, really understanding our number system and properties of operation through their work on developing addition strategies. We are still looking at Standard 6 under Operations and Algebraic Thinking, because there's really a lot there embedding this, and it also has some nice connections to other Common Core standards, both at this grade level and also at near grade levels. So we'll take a brief look at that as well. So this relationship between strategy and fluency. We want students to be strategic, and yet we know that up front that's going to take a little bit more time. At the same time, we're under pressure to get some facts fluent. So finding a balance between that is going to be important. For first grade, according to the Common Core state standards, all single-digit sums within 10 will need to be brought to automaticity, so we want fast and accurate retrieval. Oftentimes, as a rule of thumb, we say 3 seconds, but we don't have to be totally anal retentive about that. We just really want them to not have it so laborious that it gets in the way of their problem solving. We want low cognitive load on the fact retrieval. And then also students will be coming up with strategies for addition and subtraction facts within 20, and they're allowed a little more wiggle room on the time because those will be brought to fluency in second grade. So as an example, the facts off to the left are within 10, so for those we're going to want them to be fairly efficient, but the facts on the right side of the screen are within 20, and so the efficiency is in progress. Some students will probably get quite efficient by the end of the year, others maybe not so much. So I've removed the bottom right-hand corner of this chart you saw in a previous lesson. These facts that you see here are all designated for mastery and fluency in first grade. So they will be held to the fast and accurate retrieval expectation. So we're going to take a look at this chart. You'll see it several times. First, though, notice that it's color-coded, indicating that we can invest our time in a few strategies that will really simplify the learning of these facts for children. But not only will it simplify it by grouping it together in nice chunks, it will also help them develop a deeper understanding of our number system. The only two that don't have a designated strategy right here are 5 plus 3 and 3 plus 5, and we will be taking a look at a possible strategy for that before we're done. Here's a sample sequence. Notice that you start with the +1, +2 facts. That's actually more intuitive to children than starting with +0. The idea of adding nothing is counterintuitive to many children, so it's not usually the first set of facts we have them learn. Following that are the +10 facts, which also correspond to some place value number and base 10 work that you will also do in the Common Core. Sums of 10 and doubles, we've talked about how critically important they are as anchor facts. And then finally, they make 10 facts and they're using doubles. Those require the more advanced knowledge of how to incorporate decomposing number, recomposing number, the commutative and associative property as well. So the instructional sequence is that you're going to have a new strategy introduced, and that takes more than one lesson. And in the process of exploring the new strategy, you want children to notice some of the big ideas of mathematics and properties of operations, so that their work with the strategy also develops them as young mathematicians. They're searching for patterns. The capacity to search for patterns, articulate them, and be able to explore why helps to develop their intellect as well. And we want students to be able to see and make sense of these new strategies, so the use of multiple representations to help children visualize what's actually going on are very important. Now, following that stage, children Once they've seen a strategy, they understand how it works, they need some practice and experience really developing that strategy. So some targeted reinforcement, and they need that before they're actually formally assessed for automaticity. And so the last two bullet points here are actually going to be discussed in later lessons. Our focus right now is on the big ideas, properties, and patterns, as well as seeing the kinds of representations that we could use to help students see these strategies. Some of the big ideas about our number system that children should be developing in first grade as a result of their strategy work is that, one, the order of the addends doesn't matter. That is the commutative property, and the Common Core authors say that children do not need to know the name, commutative property, but the idea they absolutely need to know. The order of the addends doesn't matter. They need to know that numbers can be decomposed and rearranged. You can use them flexibly. Our number system is filled with patterns. They should come expecting to find them, searching for them, and thinking about ways they can take advantage of those patterns. And also addition and subtraction are inverse operations. We'll be exploring that one more in the next lesson on subtraction strategies. So a variety of visual images can be used. This particular image is a tape diagram. It's actually two of them, and it helps to illustrate that the commutative property works, even if we don't use that name, that the order of the 5 and the 4 doesn't make a difference. It's still 9. Once children see this concept visually, concretely, you should then write it as a number sentence, the symbolic format, because they'll notice different things about the symbolic than they noticed about the concrete. And so making the connection between the concrete and the symbolic is very important. The commutative property isn't just a little nice math property of operation to learn about. It's critically important in fluency work because it actually reduces the number of facts to be learned by nearly 1/2. There is no commutative property version of a doubles fact, so it isn't quite 1/2, but pretty close. It also helps to prepare them for some of the more advanced strategies like Make 10, where they're pulling numbers apart, recombining them in different orders. They really have to have the commutative property down pat before they're able to do that. So here we see the same fluency chart again, but now I've added a new section of light gray, and basically those are facts we don't have to worry about if children understand the commutative property well. We only have to leave one part of them. So now we've reduced the amount that have to be learned quite a bit. Let's see what else we can do. So now we're going to go into counting on, and some of the big ideas that we want children to explore in counting on is whether it matters if they count on from first or count on from larger. It shouldn't matter as far as the sum. So we want them to recognize that the sum is the same. It doesn't matter. But it actually does matter in terms of efficiency. Counting on, if you have 2 plus 7, you definitely want to count on from the 7, not from the 2. So in that respect, you want to do 7 plus 2, not 2 plus 7. And then also, what patterns do they notice? We're going to take a look at that in just a minute, but that can help them to deepen their understanding of the standard on counting and addition. Standard 5. All right, here we have a sample activity for counting on from Singapore Primary Math Textbook 1A, and you'll see at the top a really lovely visual. The thing I like about it so much is that it relates addition with the number path, which provides a kind of geography of the number system that they can navigate up and back. Then it relates that to the spoken word of counting on. So you count on from 4, 5, 6, 7. That's the thought bubble, and then it relates those to the symbolic format of 4 plus 3. This is followed up with a number of sequences of exercises, but those sequences aren't random. They are designed, if a teacher is using them in this way, to elicit patterns. So in the first example, children can explore that counting on 0 means that you stayed in the same place on the number line, and that the sum is exactly where you started. So it's the original number. They can also learn that counting on 1 and adding 1 are the same thing, that it's just the next counting number in the number word sequence. And then in the last one, part D, 5 plus 3, 6 plus 3, and 7 plus 3, they can learn that 6 plus 3 results in a sum that's 1 more than 5 plus 3. That's a really handy idea to have as you get into some of the more advanced strategies. This slide I'm going to go through quickly. It just illustrates another tool called a math rack that you could use, and you count, you only read what's on the left, and then if you counted on from 2 and you counted the 7 on the bottom, it would look like the top one. If you had 7 on the top and you just counted on the bottom, 8, 9, you can see that's a lot more efficient. So I have a variety of images here to show you different kinds of tools that you can use to communicate to students about whether the order matters. Patterns, they should at some point in this exploration see charts like this where they can explore patterns that they might notice. For example, the +2 fact is 1 more than the +1 fact. The +1 fact is always 1 more than your original addend. They might, if they explore a diagonal, for example, if you start, let's say that you're at 3 plus 2 equals 5, if you can find that one in the second column. Now if you go diagonally down to the left, you'll find 4 plus 1 equals 5. They have the same sum. And every time you go exactly in that same direction, you find they have the same sum. If a child notices that, they're beginning to get at the idea of compensation. You could model that with beads, so they could see that 5 plus 2, 5 on the top and 5 beads on the top and 2 on the bottom, is exactly the same number of beads as if you have 6 on the top and 1 on the bottom. The +0 facts, this gets at the identity property of addition, and so we want students to be able to explore this and articulate it to recognize that it holds true for both versions of the fact, the turnaround fact as well. That gets at commutative property. And here I show a different visual representation called a part-whole card, where they keep track of the 2 addends as parts, and then they write the whole down below. And I show one with counters and one with numerals. So that's another kind of thing that students can use as a representation. Our chart is coming right along here. Notice that there's only 9 remaining facts once we've learned the count on by 0, 1, and 2. And those are some of the easiest facts. So we have 9 remaining facts that have to be brought to fluency. Clearly they're going to be working with a lot more facts than this, but those facts are not held to the efficiency expectation that the facts within 10 will be. Okay, +10, some big ideas. Any number greater than or equal to 10 can be thought of as individual items or as groups of 10 with leftover items. Example, 17. I can imagine 17 individual items or a group of 10 with 7 leftovers. And that holds true for all those numbers, double-digit numbers, 10 and above. Also, adding 10 to a single-digit number results in a new place value. The ones place stays the same. That's a big idea. And then when we add 10s with 10s, we add 1s with 1s. We don't, if we had 5 10s and 2 1s, we don't end up with 7 10s and we don't end up with 7 1s. Understanding the 10s with 10s and 1s with 1s is also a big idea. Here's some different representations that can be used when you are exploring the +10 with children. Tens frames, the math rack on the bottom, the hundreds board is wonderful for exploring patterns in the number system when you add 10. And then also place value cards, which can be decomposed. So the number 14 can be pulled apart and you can see that the red 1 isn't a 1, it's really 110. Sums of 10, we want children to know these really well. Being able to understand these really well can be extrapolated and extended into understanding our number system. For example, then any number, 8, 18, 28, 38, for example, I can recognize it as being 2 less than the next decade and 8 more than the previous decade. So knowing the complements allows me to navigate the number system really well, but it has to start with knowing all those sums of 10 really well. 5 and 5, 4 and 6, 6 and 4, 3 and 7, 7 and 3, 2 and 8, 8 and 2, 9 and 1, 1 and 9, and of course 10 and 0. The doubles, some big ideas here. Doubles become very important as children develop multiplication skills. In fact, that represents some of their prime schema that they get to take with them as they start multiplication. But essentially doubling means that we're going to combine two equal-sized groups. And halving is the opposite. In second grade, children will learn that any number that can be halved into two equivalent whole number groups is an even number. So sorry. All right, so now we're down to just these facts remaining for the children to learn. So we're going to explore some possible strategies, although instead of introducing these to children, I might have an idea of something I'd like them to notice, and you'll see that the tens frames I created were designed to get the kids to notice something. But I would like the kids to name the strategy for themselves. I've just shown you here how an image can implant an idea of a strategy. So 3 and 4, children can notice that 3 and 3 is 6, and that 3 and 4 would be one more than that. Excuse me, I'm going to have to take a drink. For 4 and 5, they can do something very similar. They can say 4 and 4 is 8, and one more would be 9. That's a doubles plus 1. But they might also notice 5 and 5 is 10, so 5 and 4 would just be one less. So I told you that 3 and 5 was one of the facts that was in white. Unclear what strategy you would use. I'm going to suggest a strategy here called compensation. It sounds difficult, but notice how the visual image implants this idea. So I have a tens frame with 5 and 3. Notice I've got one in a different color because I want you to notice what I do with it. I move him down to the bottom row. So I take 1 away from the 5, give it to the 3. I've turned the whole fact into a 4 and 4. So that's a thought for you to think about with your learners. And then finally 3 and 6, maybe a student would say, well, if it were 4 and 6, it would be 10, so 3 and 6 would be one less. The tens frame helps implant this idea of how you could use 10, but in addition to that, you can use it for doubles by putting them in these little rows of 2. All right, now make 10 is where things get really interesting, and the make 10 strategies and the doubles plus or minus 1, they're going to be much more important with those facts beyond 10 as well. Some big ideas to help the students think about as they explore this is our number system. You're making 10, you're essentially turning other facts into a 10 and leftovers, and so the idea of the role of 10 is very important. And then also they are decomposing, pulling numbers apart, putting them back together in a variety of ways. So they're really going to deepen their understanding of the commutative and associative properties. These cards are called the +9 +8 cards. I'll include a link in the teaching resources for how you can find them. But basically they implant the idea that you're almost at a point where you could finish one tens frame and then call it 10. And so this implants the idea that 9 + 7 could be changed into 10 + 6. And then it's available in both versions, so the commutative property can be explored. And then once they understand it for 9's facts, it can be extended to 8 facts as well. And here are the references. In particular, if you would like a lot of activities, more than what you find in this PD module, I strongly recommend the O'Connell and San Giovanni book. It's filled with activities